told you you need to know this chart for these common amplifiers. Base, emitter, collector, right here. So what's the first thing you have to be able to do? Yeah, identify the symbol of the common amplifier. And obviously these go in order: base, emitter, collector. Identify schematic symbol. You also have to be able to determine these parameters right here that relate to each type of common amplifier. So the first one being common base. How do we know it's common base? It all has to do with mainly where the inputs and outputs are, right? Right, yes. So for this one, these little circles indicate what? Yes, either test points or an input or an output. Same, it's kind of the same thing. So we always apply our input in this course thus far where? It's always like from the left side, right? The right side left, the left side right. Output's always on the right side. Woo! So therefore, the input's where? Emitter. The emitter with respect to the what? Base. The output's on the collector with respect to the base. Is that too tough? No. Better not be. So we can start answering some questions about this now. You have to know this chart. You'll be asked questions about it. Input, emitter, output, or AC output. Because we're talking about the applying the AC signal. Because all of these are what? They're configured in the what region? Active region. Yeah. So what about the phase? Yeah, here's an input. Hey, here's an output, a little bit bigger, amplified. It's in phase. In phase. Then we have to discuss the gains: current gain, voltage gain, power gain. And during the lesson and quiz review and all these things, the current gain for the common base is what? Current gain. Our gain always has to do with the outputs, doesn't it? Yes. So the current gain is, how do we're saying low, I'm here low, but how do we know? Remember the percentages: 100% emitter, 95% collector, and about 5% of the base. So current gain, if we're taking our output at the collector, well, 95 is less than 100%, so the current gain must be low. Make sense? Yes, sir. Or less than 1. Don't forget, less than 1, low, it's the same stuff. And there's some clues I'm going to give you later. Just a reminder, hey, you can tell if it's this, if the output's like this, or the input's like that. Oh. What about the voltage gain for this thing? And mainly that boils down to, hey, I'm using it as an amplifier. My output's here, my base collector's already reverse biased. So there's some opposition there. Just think of like an open switch. Open switch, I have what? Max what? Max voltage, max resistance, basically minimal current. And don't forget, these are just relative terms. If you're looking for high and you see very high, and other distractors say low and pizza crust and banana top, well, you're probably going to pick high. I made that straight up. Banana top. Power gain. Yeah, it's kind of like, in a way, some fuzzy math, if you will, because we know that power is a product of current voltage, so it's just a relative term. Power gain high. What about the input impedance, or Z-in? The input's on the emitter. Here's one of the tips. Whenever we're dealing with the emitter, input or output, the impedance is always going to be what? Low. Because that junction, emitter-base junction, is already forward biased. So how much opposition exists? Not much at all. Low. Output impedance. What's up with that? So again, our output's at the collector, and if we're saying our voltage gain is high, think about the open switch again. oh, there's some opposition there, or a significant amount of opposition, because I'm taking the output across basically an open switch, aren't I? To keep it really simplistic. And this thing also has a nickname, which is what? Voltage amplifier. So all you gotta know about that thing. That's it. Characteristics. What about the next one? We call this the common emitter. Something like this, CB. Hey, and what you stand for to get it, buddy? CE for common emitter. How do we know? How do we know it's a common emitter? Hey, look at that thing. Inputs on the base with respect to the emitter. Outputs at the collector with respect to the emitter. And there's something cool about this one. Everything's what? High. Everything's high with a common emitter. But first things first, base, input, outputs at the collector. What about the phase relationship between the input and output? Yeah. This is a 180-degree phase shift. 180 degrees out of phase. Current gain. Current gain is high, or can we say very high? Yeah, we'll say very high, because that will indicate what our power gain is going to be, because it has to do with how it's living. But again, if you're looking for very and you don't see it, would you just pick high? Yes. That's all you see? Yeah, it's just relative. So very high, current gain. Well, the output's here on my collector. And if you want to consider this, 5% in the base, 95% on the collector, current, because I always use percentage to represent current. Could I say that that's basically equal to transistor beta? Yeah, because look, base collector. So I can do something like this, parentheses, transistor beta. Do that. What about the voltage gain? We'll call it very high again. Output is at the collector, just like this one, but we're dealing with a little bit more current, a little bit more potential here, which our result in power gain will be what? Extremely high, because very times very is extremely. And I already told you everything's what in a common emitter? High. During the lessons, we went through the how and the why. Now it's kind of a Barneyized method of going through this chart again. So far, so good? Can you do it there, Mr. Walerius?
Yes, sir.
Okay. Input impedance. Well, it's on the base, the input that is. What did I tell you about input being on the base as far as impedance goes? It's always going to be high, very high. No, you're saying low. Base! Input's on the base, it's always going to be high. What do we normally have at the base? Voltage divider resistors. The base collector is reverse bias. There's a significant amount of opposition to the input. It's always going to be high. Or very high. Got the word high in it, that's the damn answer. High. Where's the output? Collector. What's the output impedance look like? Huh? High, very high. What does your chart say when I originally gave it to you? Very high, high. Height also high. Because again, we're dealing with reverse bias, base collector. We've got collector resistor out there. From collector, we're going from collector to emitter. There's a significant amount of opposition there, and typically you're going to have an emitter resistor. So all that's taken into consideration. Nickname for this guy.
Power amplifier.
Power amp. Well, gee whiz, if everything's high, current times voltage, very times very extremely. Oh, extremely high power must be a power amp. This is the most common configuration you will see. Common emitter.